Hello, welcome to our biotechnology presentation. Today we are going to be talking about the use of ziconotide for chronic pain, starting the impact on society. The impact of ziconotide is to treat chronic pain and prevent opioid abuse. Chronic pain. What is chronic pain? Chronic pain is very common in the United States. It is the kind of pain that will never go away and is commonly caused by cancer and failed back surgeries. What are opioids and why are they a problem? Opioids include drugs like morphine and they are used to treat chronic pain. They are addictive and they do not work well as time goes on. People addicted to opioids can't function normally and many die from drug overdoses. In 2018, about 128 people died daily from opioid overdose. That is the impact on society. What is ziconotide? Ziconotide is a powerful pain-relieving drug that has a unique mechanism of action involving potent and selective blocks of N-type calcium channels, which control the pain messages to the brain. It is not addictive, and it is 1,000 times more powerful than morphine. Ziconotide is delivered from the toxin of a cone snail species, Conus magus. Initial investigations by Baldomero Oliveira on marine snail toxins began in the 1960s. Michael McIntosh discovered ziconotide in the early 1980s, when he was barely out of high school working with Oliveira. Ziconotide was approved by the Food and Drug Administration, also known as the FDA, on December 29, 2004, for use in treating chronic pain. That is the history of ziconotide. This is how ziconotide is made. Ziconotide is a man-made analgesic that is the same protein that comes from Conus magus venom. Proteins are made out of amino acids, which can be thought of like Lego blocks. Lego blocks can build many things just like amino acids can make many different kinds of proteins. Every protein has a unique number and type of amino acids. Once the specific number and type of amino acids for ziconotide was learned, scientists were able to use a protein synthesis machine to make this in a lab. Ziconotide only has 25 amino acids, so it is easy to make. That is how ziconotide is made.
My partner has told you about what ziconotide is, and now I'm going to tell you how it works. How does ziconotide work? Conus magnus snail toxin venom is used to stun the snail prey. The prey is unable to feel pain as the snail eats away. The ziconotide completely blocks the pain signals that goes through N-type calcium channels to the brain. The venom is a module that ziconotide is made to be exactly like in a lab. How is it administered? The drug must be administered by a doctor first doing surgery to put a pump under the skin. The pump looks like a hockey puck and it inserted surgically inside the abdomen or the stomach. It's called a stomach, pretty much. From the pump is a tube which carries the medicine to the spinal cord. The kind of pump is called an intrathecal pump and has to be refilled at the doctor's office every few months with an injection. The pump is surgically implanted because if you give the drug every day by shots, the spinal cord, there would be a higher chance that infection or damage could occur. And people can get shots every day by a doctor into their spinal cord. No one would do that. In conclusion, biotechnology has a positive impact on people's lives. Ziconotide is a good example since it has enabled many people to live pain-free lives. In addition to learning about how ziconotide is made and how it is worked in the body, we also have learned many skills through this project. 21st century skills. Communications. We had many experience during this project to build our communication skills. We reached out to experts like Dr. Rachel Wagner, who gave us information to help understood ziconotide and how it works. We also reached out to Dr. McIntosh, and Mr. Ragershek to use their images on our project. The collaboration. In this project, my partner and I had to collaborate through all parts of this project, from picking out the topic to research saconitide, to, div- to dividing up responsibilities. We each use our strengths to make this project better. Collaboration was hard due to our different schedules and virtual remote learning, but we made it work.
My partner shared with you 21st century skills did that we have learned through the project. I will show you now critical thinking. During our research, we had to do a lot of critical thinking because our information came from a lot of different websites. There was there were a lot of things we did not understand at first, like what an analgesic was and how the nerves worked. Summarizing the research required a lot of critical thinking to decide what was the most important things to include. Thank you for taking the time to watch our presentation. Hope you have a great day. Goodbye.